Let's look at figuring out the expansion of tan alpha in terms of alpha. Now we have already seen the expansion of sine alpha and cos alpha in terms of alpha. So we take tan alpha and we write it as sine alpha by cos alpha. Okay, since we already know what the expansion is, we can directly write that, like alpha minus alpha cube by 3 factorial plus alpha 5 by 5 factorial and on, divided by 1 minus alpha square by 2 factorial plus alpha 4 by 4 factorial minus and on and on. Now let's simplify this. Alpha minus alpha cube by 6 plus alpha 5 by 5, 4, 3, 2, 1 is 120 minus on and on. Now what we can do is, instead of writing it in the denominator, we can write it as a negative exponent. So this becomes 1 minus alpha square by 2 plus alpha 4 by 4 factorial 432 is 24 minus and on and on and on to the power of minus 1. Okay, now this here we need to evaluate this, the negative power of 1. So let's see. Let's write it as it is. Alpha cube by 6 plus alpha 5 by 120 minus dot 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 dot. Now what we'll do is we will write this as 1 plus, and the rest we take it inside a bracket, x square by 2 plus alpha 4 by 24 minus dot 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 to the power of minus 1. And now we will use the binomial expansion. So alpha minus alpha cube by 6 plus alpha 5 by 120 minus dot dot dot, and this will become, remember this is equivalent to 1 plus x to the power of minus 1, which is equal to 1 minus x plus x square minus x cube and on, right? So we just apply that as a pattern. What do we get? We get 1 minus x, here x is this part. So we write it as minus alpha square by 2 plus alpha 4 by 24 minus dot 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 plus same thing again, alpha square by 2 plus alpha 4 by 24 minus dot 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 and square, and this will go on and on and on. Okay, now let's simplify the second part again. Alpha cube by 6 plus alpha 5 by 120 minus dot 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 dot, and this will become 1 plus alpha square by 2 minus alpha 4 by 24 minus dot 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 dot, no, plus dot 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 dot, then this part, this will become, this is square, so this will become x4 by 4, sorry, alpha 4 by 4 and dot 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 dot. Now why dot dot dot, why not one more term? Because it is difficult to figure out here. The only thing we are sure of is that the first term will be a square of this. Okay, so now let's close this off. What do we get? We need to multiply these two. But before that, what we can do is alpha cube by 6 plus alpha 5 by 120 minus dot 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 1 plus alpha square by 2. We can add these two terms. So what do we get? minus alpha 4 plus 4 6. So 6 alpha 4 by 4 dot 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 dot. And this becomes plus 5 alpha 4. Denominator will be 24. Okay. Now it's you have to be very careful when you are multiplying expressions with dot 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 dots. Okay. Now let's multiply these two. Let's distribute this among these. We get alpha plus alpha cube plus 5 alpha 5 by 24 and dot 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 dot. Now let's use the second term and distribute it. We get minus alpha cube by 6 minus alpha 5 by 12 minus um, 5 alpha 7 by 24 times 6 and so on. We can distribute this as well here, yes, but we will keep it simple. Okay, so now here if you notice we have alpha to the power of 5, alpha to the power of 5, alpha to the power of 3, alpha to the power of 3. Why is there no denominator here by 2? Okay, so now alpha plus alpha cube, here we have half and here we have minus 1 by 6 plus alpha to the power of 5, 4 we don't have, here we have 5 by 24 and here we have minus 1 by 12. Okay, and now we need to be careful because for alpha to the power of 5 there is one more term possible, right? If we multiply this with 1, so let's add one more term here, alpha to the power of 5 by 120. Now you won't have alpha to the power of 5 again, right? Okay, so now this becomes um, plus alpha to the power of 5 by 1. Okay, now let's simplify this. Alpha plus alpha cube, this is what, 3 minus 1, 2. So 2 by 6 is 1 by 3 plus alpha to the power of 5 times, now here you will have 24 fives is 120, so 5 fives 25 minus 12 tens, so 10 plus 1 by 120, and here you remember you have dot dot dot. So our expansion is alpha plus alpha cube by 3 plus, so this will be 16 alpha 5 by 120, which works out to 8 to 16, 8 ones 8, 8 fives 40. So that means we can finally write this as alpha cube by 3 plus 2 alpha 5 by 15 dot dot dot. So that is the expansion of tan alpha in terms of alpha. Now here the tricky part was to divide the or apply the binomial theorem, right? So what we could have also done was, remember we had this division, alpha minus alpha cube by 3 factorial plus alpha 5 by 5 factorial minus dot 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 divided by 1 minus alpha square by 2 factorial plus alpha 4 by 4 factorial dot 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 dot. What we could have done was done the division normally what we would do. So let's first simplify this, alpha cube by 6 plus alpha 5 by 120 dot 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 divided by 1 minus alpha square by 2 plus alpha 4 by 24 dot dot dot. So let's do the division. So alpha minus alpha cube by 6 plus alpha 5 by 120 minus divided by 1 minus alpha square by 2 plus alpha 4 by 24 minus Okay. Now let's multiply it by alpha minus alpha cube by 2 plus alpha 5 by 24 and okay, minus plus minus, so this cancels, and here we are left with alpha cube by 3, and here we are left with minus 4 alpha 5 by 120. So those two will get cancelled and we can write it as by 30. Okay? Now let's multiply again. Plus alpha cube by 3. So alpha cube by 3. And of course here dot is there. So alpha cube by 3 minus alpha 5 by 6. And dot. So minus plus this cancels. And here we are left with 2 by 15 alpha 5 dot. Again let's multiply 2 by 15 alpha 5, 2 by 15 alpha 5 dot. So this gets cancelled. If you want to proceed, we need to add a few more terms. Okay, so we'll just put it as dot. So our result is the same. What is that? The result is tan alpha is equal to alpha plus alpha cube by 3 plus 2 alpha 5 by 15 plus dot. So that is the expansion. We can do this doing division like this, or we can do it using binomial expansion. So that's it. Bye.